Hello guys, and welcome to our channel. This is Dixon from Maths Wiz, where we teach mathematics and mathematical sciences. We welcome you to watch, learn and enjoy mathematics with us. At the end of the video lesson, we request you to hit the subscription button below so that you can be getting future lessons as soon as they are released. Welcome. This is our fifth lesson in the series Mathematical Equations. In this lesson, we are going to determine solutions of trigonometric equations. In the introduction part, we have the following to note. 1. Trigonometric equations are equations whose variable is expressed in terms of trigonometric function value. And the number 2, in solving trigonometric equations, the procedures for algebraic equations are going to be followed. In this lesson, we are going to be guided by the following principles. 1. The trigonometric ratios. In the trigonometric ratios, we have the following. If we consider a right-angled triangle ABC, in relation to this angle, theta, this side is the opposite side, this side is the adjacent side, and this side is the hypotenuse side. Hence, we have the three trigonometric ratios are the sine of the angle theta is equals to opposite over hypotenuse. Cosine of the same angle theta is equals to adjacent over hypotenuse, and the 3 tangent of theta is equals to opposite over adjacent. If we light the opposite side in terms of the sine and hypotenuse, we are going to get that opposite is equals to sine theta multiplied by hypotenuse. And if we light adjacent in terms of the cosine and hypotenuse, we have adjacent is equals to cosine of theta multiplied by hypotenuse of theta. From tan theta is equals to opposite over adjacent, we have sine theta multiplied by hypotenuse over cosine of theta multiplied by hypotenuse, and the hypotenuse cancels. We are left with tangent of theta is therefore equals to sine theta over cosine of theta. Further, we have 1 over tangent of theta is defined as cotangent of theta, written as cot theta. 1 over sine of theta is called cosecant of theta, written as cosec theta. And 1 over cosine of theta is secant of theta, written as sec theta. Our second important note to consider is the unit circle. The unit circle is drawn with the center at the origin and radius equals to 1 unit. And from it, we have the following. This is called the first quadrant, this is called the second quadrant, this is the third quadrant, and this is the fourth quadrant. Angles in the unit circle are laid anti-clockwise from positive x-axis, meaning that at this point this is angle 0 degrees, or this is 90 degrees, this is 180 degrees, and this is 270 degrees, whereas back at 0 we have 360 degrees, a full turn. If we consider an acute angle, that is in this quadrant, and we say that the angle is equals to theta degrees, it is related to 3 other angles in each quadrant by the following rule. In the second quadrant, we have angle 180 minus theta degrees. In the fourth quadrant, we have 180 plus theta degrees. And in the fourth quadrant, we have 360 minus theta degrees. The trigonometric ratios of these 4 angles are equal in magnitude, but differ in sign using the following rule. In the first quadrant, all the 3 trigonometric ratios have their values being positive. In the second quadrant, only sine is positive. Third quadrant, it is only tangent that is positive. Whereas in fourth quadrant, it is only cosine that is positive. The third idea to consider involves the trigonometric identities, where we have a sine squared theta plus cosine squared theta is equals to 1. From this identity, if we divide throughout by sine theta squared, we are going to get a sine squared theta divided by sine squared theta plus cos squared theta divided by sine squared theta is equals to 1 over sine squared theta. The first term reduces to 1, the second term reduces to 1 over tan squared theta, the right hand side reduces to cosecant squared theta, which can also be written as 1 plus 1 over tan is cotangent squared theta is equals to cosecant squared theta. 3, if we divide identity 1 throughout by cosine squared theta, we are going to have sine squared theta over cosine squared theta plus 1 is equals to 1 over cosine squared theta, which can be written as tan squared theta plus 1 is equals to secant squared theta. Number 4, we have the double angle formula, which are defined as the sine of 2 theta is equals to 2 sine theta cos theta. B, cosine 2 theta is equals to cos squared theta minus sine squared theta. And using the first identity, we can be in a position to replace cosine squared theta and sine squared theta to get this is equals to, if we replace the cos squared theta, we are going to get this 1 minus 2 sine squared theta. If we replace the sine squared theta, we are going to get this is equals to 2 cos squared theta minus 1. And C, we have tan of 2 theta is equals to 2 tan theta over 1 minus the tan squared theta. We now solve a number of trigonometric equations. We are going to start with category A of first degree equations, whereby we have an example. So question 1, we have 4 sine theta plus 5 is equals to 7 for theta lying between 0 degrees and 90 degrees. Like the algebraic equations, the first thing we do is we take like terms together. 5 crosses to the right hand side. We have 4 sine of theta. We divide both sides by 4. We get the sine of theta is equals to 2 over 4, which is equals to a half. From there we therefore have theta is equals to sine inverse of 1 over 2, and this one gives us 30 degrees. For question 2 under this category, where we have 4 sine theta plus 20, this is equals to 2 for theta lying between 0 and 360. Let's divide both sides by 4, and we have sine of theta plus 20 is equals to again 2 over 4, which is equals to a half, which implies to us that theta plus 20 is equals to sine inverse of half, and this is equals to 30 degrees. Notice from the unit circle, with theta equals to 30 degrees and our sine is positive, the possible values of theta lies between the first quadrant and the second quadrant. Angles in the second quadrant are determined using the formula 180 minus theta, and since our theta is equals to 30, it therefore means that either the angle is equals to 30 degrees, or we have theta plus 20 degrees is equals to 150. For each quadrant, we can get the direct value of theta, so therefore this one will be that with theta, from theta plus 20 is equals to 30 degrees, we have in this case our theta is equals to 10 degrees, and from theta plus 20 degrees is equals to 150 degrees, theta is therefore equals to 130 degrees. In our second category, we have solutions involving factorization of trigonometric equations. We have the first example under this category is equals to 3 tangent of the theta squared minus 5 tan theta is equals to 2. Realize that this one is a quadratic equation, which is of the form 3 tan squared theta minus 5 tan theta minus 2 is equals to 0. By using factorization method, we determine our two values p and q such that when they are multiplied, they equals to minus 6, and when p is added to q, we are going to get minus 5, and by the factors of the two values, we get minus 6 and positive 1. Hence our equation will reduce to 3 tan squared theta minus 6 tan theta plus tan theta minus 2. In the first category, we factor out the common term. In the second category, we factor out the common term in the first category. 3 tan theta is common. We are left with tan theta minus 2. In the second category, plus 1 is common. We have tan theta minus 2. Everything is equals to 0. First bracket, we have 3 tan theta plus 1. Tan theta minus 2 is equals to 0. Therefore, in this case, our two solutions are either 3 tan theta plus 1 is equals to 0, which implies that our tan theta is equals to minus 1 over 3, and therefore theta is equals to tan inverse minus 1 over 3, which will be equals to minus 18.43 degrees. Our second option is tan theta minus 2 is equals to 0, which will imply that tan theta is equals to 2, or our theta is equals to 63.43 degrees. Our second question under this category is 2 sin theta minus 1 is equals to 3 over sin theta, with the value of thetas lying between 0 and 360. The first thing we are going to do is we are going to multiply the root by sin theta to remove the denominator, where we are going to have 2 sin squared theta minus sin theta is equals to 3, which can be rearranged as 2 sin squared theta minus sin theta minus 3 is equals to 0. In this case, we determine our two values p and q such that when they are multiplied, they are equals to minus 6, and when p and q are added, they will give us minus 1. We are going to get our values as minus 3 and positive 2, so that we have 2 sin squared theta minus 3 sin theta plus 2 sin theta minus 3, everything is equals to 0. In our first category, we have sin theta into bracket 2 sin theta minus 3. The second category, plus 1 is common. We have 2 sin theta minus 3 is equals to 0, which can be written as sin theta plus 1, 2 sin theta minus 3 is equals to 0. Our two solutions are either sin theta plus 1 is equals to 0, or 2 sin theta minus 3 is equals to 0. From the first option, we have sin theta is equals to minus 1, which implies that theta is equals to minus 90 degrees. Notice that the value of theta we are looking for should be between 0 and 180 degrees, so we're going to go to the unit circle. We locate minus 90 degrees, so we have this is 0 degrees, this is minus 90 degrees in clockwise direction, whereas in the anti-clockwise direction the angle is equivalent to 270 degrees. Hence our theta 1 is equals to 270 degrees. From our second option, we have 2 sin theta is equals to 3, which implies that sin theta is equals to 3 over 2, and we say that since sin theta lies between 0 and 1, then we say that this answer is not practical. Question 3 under this category, we have 2 sin theta cos theta plus sin theta is equals to 0. We factor out sin theta on the left hand side to have sin theta into 2 cos theta plus 1 is equals to 0, and we have either sin theta is equals to 0, and this implies that theta is equals to 0 degrees, or theta can also be equals to 180 degrees. The second option, we have 2 cosine of theta plus 1 is equals to 0. This one will tell us that cosine of theta is therefore equals to minus 1 over 2. Hence, our theta in this case will be equals to 120 degrees. Notice from the unit circle, notice that cosine is negative in the second quadrant and the third quadrant. Hence, the second option for theta is therefore equals to 180 plus theta. But in the second quadrant, notice that 120 degrees is equivalent to 180 minus theta, which implies that theta for this case is equals to 60 degrees. Hence, in the third quadrant, the angle in question, theta 1 is therefore equals to 180 plus 60, which is equals to 240 degrees. We now look at the questions that involve substitutions of trigonometric identities. Our first question, we have cosine of squared theta plus sine of theta is equals to 1. In this question, we have cosine and sine together. From the first trigonometric identity, we had cosine squared theta plus sine squared theta is equals to 1. We can rewrite this equation and we make cosine squared theta the subject of the formula. Then we substitute it in the equation above, where we're going to have cosine squared theta is equals to 1 minus a sine squared theta. And this value we have got, we can comfortably substitute it at the cosine squared theta, where we are going to get 1 minus sine squared theta plus sine squared sine plus sine theta is equals to 1, and the equation reduces to minus sine squared theta plus sine theta is equals to 0. We factor out sine theta and we have sine theta into minus sine theta plus 1 is equals to 0, which will give us either sine theta is equals to 0, which implies that theta is equals to 0. Alternatively, we have 1 minus sine theta is equals to 1, which implies that theta is equals to 90 degrees. Second example under the category, we have 2 sine theta plus 1 is equals to cosec. Recall that 1 over sine theta is equals to cosecant theta. Thus, 2 sine theta plus 1 is equals to 1 over sine theta, which can as well be written as 2 sine squared theta plus sine theta is equals to 1, or 2 sine squared theta plus sine theta minus 1 is equals to 0. On factorization, this becomes 2 sine theta minus 1 into sine theta plus 1 is equals to 0, which we have either 2 sine theta minus 1 is equals to 0, which would imply that theta is equals to sine inverse a half, and therefore theta is equals to 30 degrees. The second option, we have sine of theta plus 1 is equals to 0, which implies that sine of theta is equals to minus 1, which will tell us that our theta is equals to 270 degrees.
This is Dixon again from MathsWiz, where we teach mathematics and mathematical sciences. We hope you have enjoyed our today's lesson. We remind you to hit the subscription button below so that you can subscribe to our channel and be getting future lessons as soon as they are released. Thank you for your watching.